Hello, my dear students. Today we are going to continue chapter 5, which is organic chemistry. We are going to discuss the alkenes and the nomenclature of alkene and their physical properties. And we are going to discuss the ethylene molecule, its preparation and its chemical properties. And we are going to discuss the different types of polymerization of alkenes, and we are going to discuss their uses in our life. So let us start. Alkenes that has general molecular formula CnH2n. The nomenclature of alkenes. The name is according to the longest continuous chain as alkane, but putting the suffix ene preceded by the number of carbon atom nearest to the double bond. As shown on the screen, this molecule contains 3 carbon atoms. So here numbering of carbon atom is not needed, so we call it propene. But another example here, the double bond between the carbon atom number 2 and 3. So we are going to name this molecule by 2-pentene. We write the number of carbon atom that nearest to the double bond. So the double bond between 2 carbons, 2 and 3, so the name of the double bond, it will be 2, not 3, the lowest number here. So my dear student, the second rule, numbering the carbon atom chain starts from the nearest side to the double bond regardless to the position of the other group. So this example as shown on the screen, so its name will be 3-methyl-1-butene. Another example as shown on the screen, so its name it will be 4-chloro-1-butene. Now, my dear students, we are going to discuss the ethylene molecule or ethene that has molecular formula C2H4. The preparation in lab. By removing water from ethanol C2H5OH using hot concentrated sulfuric acid at 180 degrees Celsius. Here, my dear student, we heat the mixture of concentrated sulfuric acid and ethanol by temperature 180 degrees Celsius and passing the gas over sodium hydroxide, then collecting the ethylene gas above the water as it is insoluble and lighter than water as shown on the screen. So, my dear student, as shown on the screen, the concentrated sulfuric acid and the ethanol react with each other, giving the ethylene gas and collected above water as shown on the screen. So the dehydration of ethanol happens by the following reaction. C2H5OH in the presence of concentrated sulfuric acid at 180 degrees gives the ethylene releasing water. So the reaction steps, ethanol reacts with sulfuric acid at 80 degrees Celsius, giving ethyl hydrogen sulfate, and water is produced. Then, on thermal decomposition of ethyl hydrogen sulfate, ethylene is formed, releasing sulfuric acid again. Now we are going to discuss the physical properties of alkenes. The first members of alkenes are gases, while from 5 carbon atoms till 15 carbon atoms are liquid, while over 15 carbon atoms are solids. These alkenes are nonpolar compounds and insoluble in water, but dissolve in organic solvent as benzene. Now we are going to discuss the chemical properties of alkenes, and we are going to discuss the chemical properties especially for ethylene. Now we are going to talk about the burning of ethylene. Ethylene on combustion as any hydrocarbon it gives carbon dioxide and water and releasing large amount of heat energy. So my dear student, as we burn the ethylene gas, it produces carbon dioxide and water vapor as shown on the screen. Now, my dear students, we are going to discuss the chemical reactions of ethylene. The chemical reactions of ethylene are addition reactions, as the pi bond is broken down and saturated compound is formed. The first type is hydrogenation. Here, as shown on the screen, ethene, when reacts with hydrogen at 150 degrees Celsius till 300 degrees Celsius in the presence of catalyst nickel or platinum, they form ethane, as shown on the screen. So, my dear students, the unsaturated vegetable oils as maize oil contain double bond between the carbon atom, which is broken on hydrogenation and turns into solid artificial fats. Now, the halogenation reaction of ethylene. When bromine solution dissolved in carbon tetrachloride is added to alkene, its red color disappears. The reaction between alkene and the halogen is used for testing the unsaturation or the presence of pi bond. If we use alkane and alkene and adding bromine to both of them, we find that the red color of bromine remains in alkane. While we are going to put it on alkene, the red color of bromine will be removed, indicating that the pi bond is broken down, and here the bromine color will be removed. So the equation of the reaction as shown on the screen, ethylene plus bromine in the presence of carbon tetrachloride as solvent for bromine gives 1,2-dibromoethane as the double bond is broken and the alkane compound is produced, and it is disubstituted alkane as it will be 1,2-dibromoethane. The reaction of ethylene with hydrogen halide. Here, my dear student, we have two different types of alkenes: symmetric alkenes, which the double bond between two carbon atoms have equal number of hydrogen atoms as ethylene. Here, adding HBr, it forms bromoethane or ethyl bromide as the equation shown on the screen. While the asymmetric alkenes, here the double bond between two carbon atoms having an equal number of hydrogen atoms as the molecule shown on the screen, which is propene. Here we have to apply Markovnikov rule, which states that on adding asymmetric reagent as halogen acid HX or sulfuric acid HOSO3H to unsymmetric double bond, the positive part of the reagent is added to the carbon atom that reach in hydrogen, while the negative part, halogen or OSO3H negative ion, is added to the carbon atom that pour in hydrogen. So the equation of adding hydrogen bromide gas or hydrobromic acid on propene or propylene, it gives 2-bromopropane, not 1-bromopropane. So we have good reason in this point. 1-bromobutane is not formed on adding HBr or hydrogen bromide gas to 1-butene, because according to Markovnikov rule on adding a symmetric reagent such as HBr to unsymmetric double bond, the positive part of the reagent, which is positive hydrogen ion, is added to the carbon atom rich in hydrogen, while the negative part, which is bromide ion, is added to the carbon atoms that pour in hydrogen. So the equation of the reaction proceeds on the screen. 1-butene plus hydrogen bromide, it gives 2-bromobutane as the bromine atom is added to the carbon pour in hydrogen of the double bond. Another good reason in this point. Marconic rule is not applied on adding HBr to 2-butene because 2-butene has symmetric double bond, so the hydrogen atom of HBr is added to any carbon atom of the double bond. As the equation proceeds on the screen, 2-butene plus hydrogen bromide gas, it gives 2-bromobutane as shown on the screen. Now we are going to discuss the addition of water. The catalytic hydration of ethylene. This is the reaction of water with the organic compound in the presence of catalyst. As the water is weak electrolyte, so the concentration of positive hydrogen ion is very weak and they cannot break the double bond. Therefore, the reaction occurs in the presence of a strong acidic medium to supply enough positive hydrogen ion to increase the concentration of hydrogen ion as the equation proceeds on the screen. C2H4 plus H2O 80 till 110 degrees Celsius in the presence of concentrated sulfuric acid, it gives ethanol or ethyl alcohol C2H5OH. The reaction steps: C2H4 plus HOSO3H sulfuric acid at 80 degrees, it gives ethyl hydrogen sulfate as the sulfuric acid breaks the double bond and added to the ethylene. And then the water reacts with ethyl hydrogen sulfate, which is called hydrolysis. It gives ethanol and releasing sulfuric acid again. Now we are going to discuss the oxidation reaction. Here, my dear student, we call it Bayer reaction. It is adding dilute potassium permanganate in alkaline medium to ethylene, giving ethylene glycol, which is dihydroxy compound. Here, my dear student, we use alkaline potassium permanganate and we are going to prepare ethylene gas and passing the produced ethylene gas over the dilute alkaline potassium permanganate, and we are going to show that the violet color of potassium permanganate will be removed on adding ethylene on it, as shown on the screen. So the equation of the reaction of Bayer reaction as shown on the screen: ethylene plus water plus atomic oxygen produced from potassium permanganate that present in alkaline medium, it gives ethylene glycol or 1,2-dihydroxyethane. So we have good reason in this point. Bayer's reaction is used to test for the double bond or unsaturation because the violet color of potassium permanganate is removed. My dear student, note that hydrogen peroxide H2O2 can be used also for oxidation of ethylene and giving ethylene glycol. The equation of the reaction proceeds on the screen. C2H4 plus H2O2 gives ethylene glycol or 1,2-dihydroxyethane as shown on the screen. We have good reason, my dear student, in this point. Ethylene glycol is used as antifreeze substance in car radiator in cold countries because it forms a hydrogen bond with water molecules, preventing their combination with each other, forming ice crystals. Now we are going to discuss the polymerization of alkene. It is joining a small chain unsaturated hydrocarbon called monomers, giving long chain hydrocarbon called polymers with the same empirical formula. Types of polymerization reaction. Addition polymerization, it takes place by adding a huge number of unsaturated small molecules to each other to form very large molecule, such as the formation of polyethylene. Their number ranges from 100 to million molecule, such as the formation of polyethylene as the following animation show. Here, my dear student, we have two molecules of ethylene and so the double bond, the pi bond, will be broken and the molecules join with each other, and according to the number of ethylene molecules that can join with each other, they form the large molecule that produced from their joining. So my dear students, the polymerization of ethylene is heated under high pressure, about 1000 atmosphere, in the presence of oxygen as initiator, as the equation show on the screen. NCH2 double bond CH2 in the presence of catalyst and pressure gives the polyethylene molecule as shown on the screen. Now, my dear students, we are going to discuss the condensation polymerization, which is second type of polymerization. It takes place between two different monomers that lose a simple molecule as water on joining, and the produced copolymer is the basic unit for polymerization process. Now we are going to show the different types of polymerization of alkene to form addition polymerization forming polymers. Here the first monomer is called ethene, and the polymer produced as shown in the screen is called polyethene, and its commercial name is polyethylene, and its property soft and tolerant, and the effect of chemicals, and its use in plastic sheets, bags, bottles, and hoses. The second monomer of alkene that we are going to show its polymerization is propene. Its polymer as shown on the screen is called polypropene, PP. Its commercial name is polypropylene, and the property of it hard and rigid and used for carpets, cases, and cans. Next monomer here it will be chloroethene or vinyl chloride. Its polymer as shown on the screen, it's called polychloroethane, and its commercial name polyvinyl chloride PVC, and its property is rigid and hard or soft, used in drainage tubes, plastic tubes, shoes, hoses, electric wires, insulators, and oil bottles. Next monomer here is chloroethene or vinyl chloride. Here its polymer as shown in the screen, polytetrafluoroethene, and its commercial name is Teflon, and its property resist heat and adhesion, and electric insulator and inert, and used for cooking utensils and surgical threads. Questions. Choose the correct answer. The number of hydrogen atoms in an alkene having 5 carbon atoms is what? 5 or 10 or 14 or 12? If you think about it, yes, it will be 10. The number of carbon atoms in alkene having 12 hydrogen atoms is what? Is it 14, 7, 6, 5? If you think about it, it will be 6. The molecular formula of an alkene having 10 hydrogen atoms is what? Is it C5H12 or C5H10 or C5H14 or C5H8? If you think about it, yes, it will be C5H10. My dear student, solving these questions by applying the rule CnH2n. Next point, PVC is produced from the polymerization of what? Tetrafluoroethene, vinyl chloride, propene, ethene. If you think about it, yes, it will be vinyl chloride. Next point, the number of sigma bonds between the carbon atom and the hydrogen atom in an alkene having 3 carbon atoms is what? Is it 4, 8, 10, 6? If you think about it, yes, it will be 6. Next point, the number of sigma bonds between carbon atoms in alkene having 5 carbon atoms is what? 3 or 5 or 6 or 4? If you think about it, yes, it will be 4. Next point, the number of sigma bonds in an alkene having 4 carbon atoms is what? Is it 4, 8, 10, 11. If you think about it, yes, it will be 11. Next point, alkenes are considered from what kind of hydrocarbon? Is it open chain unsaturated hydrocarbon, unsaturated cyclic hydrocarbon, or open chain saturated hydrocarbon, or saturated cyclic hydrocarbon? If you think about it, yes, it will be open chain unsaturated hydrocarbon. Next point, the molecular formula of an alkene having 6 carbon atom is what? C6H10 or C6H12 or C6H14 or C6H6. If you think about it, my dear student, it will be C6H12. Next point, my dear student, the number of sigma bonds between the carbon atoms in alkene having 5 carbon atom is what? 3 or 5 or 6 or 4. If you think about it, my dear student, yes, it will be 4 sigma bonds. Next point, the molecular formula of an alkene having 18 atom is what? C8H12, C6H12, C7H13, C5H12. If you think about it, yes, it will be C6H12. The number of sigma bonds between the carbon atoms in alkene having 5 carbon atom is what? Is it 3, 5, 6 or 4? If you think about it, it will be 4. The molecular formula of alkene having 18 atom is what? If you think about it, yes, it will be C6H12. Next point, compounds having molecular formula C2H4 is considered from what kind of hydrocarbon? Is it unsaturated aliphatic or saturated aliphatic or saturated cyclic or A and C together? If you think about it, it will be unsaturated aliphatic. Next point, all the following alkenes are symmetric except CH2 double bond CH2 or CH3C CH3 double bond CCH3O2 or CH3CH double bond CH3 or CH3CH double bond CH2. If you think about it, yes, it will be number D, CH3CH double bond CH2, as the number of hydrogen atom between the 2 carbon atoms of the double bond are unequal. So it is unsymmetric, but all the previous molecules are symmetric alkene. Next point, addition of unsymmetric reagent to unsymmetric alkene obeys what kind of rule? Is it Hund's rule, Markovnikov rule, Schiff's rule, or Bayer's rule? If you think about it, yes, it will be Markovnikov rule. Next point, compounds having molecular formula C3H6 is considered from what kind of hydrocarbon? Unsaturated aliphatic or saturated aliphatic or unsaturated cyclic or aromatic? If you think about it, yes, it will be unsaturated aliphatic. Next point, in alkene, each compound exceeds than the previous one by what kind of group? Is it methyl CH3, ethyl C2H5, methylene CH2, or ethyl CH3CH2? If you think about it, will be CH2. Next point, the number of methyl groups in 2-methyl 2-pentene is what? Is it 3 or 2 or 5 or 4? If you think about it, yes, it will be 3. Next type of question, give a IUPAC name of. If you look at the following example on the screen, you will find the number of carbon atoms starts from the carbon nearest to the double bond, so its name will be 2-bromo-1-butene. Next one, if you start the numbering of carbon atom here, so the name of the compound will be 2,3-dichloro-1-butene. Next molecule, if you are going to name this compound, you have to start numbering of carbon atom nearest to the double bond, regardless to the groups. So it will be 2-bromo-3-methyl-1-butene. Next compound as shown on the screen, starting carbon atoms from nearest to double bond, so its name will be 2-bromo 3-chloro 1-butene. Next molecule, if you name this molecule by starting number of carbon atoms near to the double bond, so its name will be 3-ethyl 2-methyl 1-pentene. Next molecule, if you are going to numbering carbon atoms and naming the branches in alphabetic order, so its name will be 2-bromo 3-ethyl 2-pentene. This next example, it will be 2,3-dimethyl 2-pentene. Next one, 3,3-dimethyl 1-pentene. Next type of question, write your objection on the following nomenclature. 1-chloro-4-butene. If you draw the structure formula of this molecule and you are going to start numbering of carbon atom near to double bond, so its name will be changed. It will be 4-chloro-1-butene. Next molecule, 2-ethyl 1-propene. If you draw this molecule and start carbon atom numbering to the double bond and longest chain, so it will be 2-methyl 1-butene. Next example, 2-methyl 4-butene. If you draw this molecule and you are going to start numbering of carbon atom of the longest continuous chain, so its name will be 3-methyl 1-butene. My dear students, we have reached to the end of our program today. I hope you understood all the points and examples that we discussed today. So till we meet again, my best wishes for you.